All right, what's up, guys? Back at it. Let's finish what we uh couldn't finish yesterday. Subsets. Let's learn this thing. Also would want to do some linked list, some chill linked list questions, like these. I guess we can start with reverse linked list because that should be pretty easy, right? Um, yeah. But I do want to learn this though. So let's check how this is done. Like this was my attempt yesterday. Completely wrong, obviously. I need to learn the subsets algorithm straight up. I don't even know what it is, right?
Hey everyone, welcome back. Let's write some more neat code today. So today let's solve the problem subset. So we are given an integer array nums, and all we need to do is return every.
Should I stream, by the way? Like, because I'm in front of my computer every day anyways. I might as well stream it. Stream my progress. So you guys can see what's going on. Maybe, maybe.
Every single possible subset that we could create from the input nums. And we do not want to include any duplicate subsets. So what is a subset? Well, let's say we have 1, 2, 3 as our input. One subset, of course, would be 1, right, by itself. Another subset would be 2 by itself. We could do 1, 2 together. Now, what happens if we do 2, 1, right? We just swap the order. Does that count as a different subset, or is that the same as this subset? Well, they're the exact same. We don't care about the order. This is not a permutation. This is a subset. So it's not a permutation, it's a subset. So we do not want to include duplicates, and this counts as a duplicate. We're not going to include it. And 3 is another subset. 1, 3, 2, 3, 1, 2, 3. The original input is technically also a subset. And we also don't want to forget the empty subset. So no matter what we're given, an empty subset is technically a subset of this as well. So if we want to create all the subsets from this input, we have a choice for every single element. So for this one, we have a choice of include the one in our subset or not include the one, so we get an empty subset, right? So we have that choice, and we have that choice for every single input element. So in total, we have 2 choices here, 2 choices here, and 2 choices here. So this is going to be 8, or in other words, 2 to the power of n, where n is the size of our input, right? So this is the number of subsets, and we don't want the number of subsets. We actually want the subsets themselves. So how long could a subset be, right? Well, we could have a subset 1, 2, 3, right? The size of our input. We could also have subsets that are smaller, right? Like 1, 2, maybe 2, 3. So as you can tell, this is not going to be an efficient problem to solve. We have this many subsets, and each subset could be up to length n. So the worst case time complexity of this problem is going to be n times 2 to the n, regardless of how efficient we make it. Because given the constraints of this problem, we don't want the number of subsets. We want the subsets themselves. We have to make it inefficient. So with this in mind, we can just jump straight into backtracking, which is the brute force way of solving this problem, but it's also pretty much the most efficient way. So like I said, for each of these elements, we have a choice. So I'm going to draw the decision tree. So first, we can choose to add one
What?
or not add one. And that will give us 2 subsets, one subset with just one and one empty subset. So along this path, we can decide now, do we want to add 2 or not add 2? So with one decision, we will add 2, and the other decision, we won't add 2. 3, get 1, 2, 3. If we don't add the 3, then we will remain as 1 do not. Right? 2, we'll get a single empty subset. Now you can see we keep multiplying by 2, right? So here we had 1, we multiply by 2. Now we have two subsets over here, right? We go down again, we multiply by 2. Now we have four subsets over here, right? Then we go down one more time. This is our result. This is what we're tracking solution in code. Let me show you right now. So let's do this in this very one, and
This seems
if
pretty
it's greater
retarded.
than or equal to the length of our input, we know we're out of bounds. And in that case, we can just return. Now, what like data structure am I going to use to build each subset? I'm going to have an array. I'm going to allocate it outside of the function so that we have global access to it inside of this function, right? So let's say let's actually call it subset. Let's say that it has the subset that we currently have. If we ever reach the base case, we know we've gotten past our leaf node. So what we can do is add that to our result. And
I see. So he's approaching it like a tree. Okay, that does help a lot. Um, um, oh, oh, oh. I think I have more of a idea now. Um, so I think I probably. Hmm. Res, and this would be like DFS nums not size, right?
also going to add a copy of the subset because
Weird, but very weird. Then if I is bigger than nums dot size, then and then subset dot. Boom, 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 boom. I don't really know how to do this.
Because the way it works in Python and in most languages, this subset is going to be modified, right? So we know we have two decisions. So this is the decision to include nums of I. So this is like a left decision that I showed you in the picture, right? So what I'm going to do is to the subset, I'm going to append nums of I. And then I'm going to recursively run depth first search on the next element. So I plus one. So this is going to be like the left branch of our decision tree.
Yep.
And this is going to be the decision.
There will be hella memory though.
Not, but I'm basically going to do the same subset into result. So as you can see,
And then it's done, right? Yeah. So maybe give it a vector of int nums. So maybe num doesn't change, right? 愛可以是個最佳拯救，你想嗎？來握緊我這雙手，留在彼此的身邊，牽着手再繼續飛。期望擁抱到最終，所有幸福都保起。Yeah, I have to include the equals because if I equals to num dot size, then this would not be valid, right? Because nums cannot be the index would not be equals to the size, so that's kind of fucked. Um, maybe this is right. Okay, so the genius of this is recognizing that you have to think of it as a tree, right? That's pretty fucking genius too, yeah. Yeah. If it's zero, um, let's just use one, two, three as an example, right? I starts at zero. Um, I'll push back zero. Subset pushes back zero, and then I'll call it on one, pushes back zero, one, and then I'll call it on two. So it has element zero, one, and two in subset, and then once it's passed, then I will return. And then I will pop the second element. So it's one and two, and that returns. Then I will pop. Yeah, that's pretty fucking smart. One, two returns, and then one, three returns. Wow. 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 It is kind of amazing, man. So in his tree graph, right? In his tree graph, in the guy's tree graph, I'm going, I add, and then I add, and then I add, right? I come back, I go right. I come back, I come here, and I come here. And then I come here. And I come back, I come back, and then I come back, and then I come here, and then I come here, and then I come here. And then I come back, and then I come here. And I come back, and then I come here. And I come back, and then I come here. I come back, come back, come back, come back, come back. It's 1, 2, 3, 1, 2, 1, 3, 1, 2, 3, 2, 3, 0. Like that's crazy though. Like that's fucking crazy though. That's smart as hell, man. Honestly, turning this question into a tree is the genius part. Like, and then the DFS is pretty standard stuff, right? Um, I would not have gotten that for sure. Like, how would you even think of that? It's smart as fuck. uh, what was it? Subsets. Okay, so you would want a vector of vector color, so it's subset, right? So this is to save memory, and then if I is bigger or equals, that's the base case, right? Else, next, right? And then you would do the base back, no ambiguity there, nums. So what you want to do is you call it on 0 and nums return result. Boom. Cool. Um, Reverse linked list is just creating the head and then setting the head's previous as 0, and then the previous is 0, previous is 0. Oh, but it's only next. Ah, I see. Okay. So one's next will be 0. Um, and then two's next will be 1. I don't think it's that difficult. I don't think it's that difficult. Reverse list. What the fuck? Oh, it's here. Oh. This is what I'm used to doing. It's just iterating it, which is not difficult. Um, but yeah, okay. Learning um a little bit of backtracking. Is that the normal like way to do it for all of these backtracking questions? So we just turn it into a tree. Is that what this is? Maybe I'll do it tomorrow. Maybe I'll do it tomorrow. Cool. Gonna go back to the lectures now. Really want to get my FPGA network protocol project going. I still don't exactly understand what I'm doing. But we'll get there. Peace.